All right, I guess it's time to start. Welcome, guys, and thank you for joining this talk. It is going to be about bypassing secondary storage for VM deployments in Cloudstack. So this is my first conference, the first one I'm attending. I am Nicolas Vazquez, and yeah, I would like to start by introducing myself a little bit for you to get to know me. What's going on? Sorry, this was working somehow. Check again. Yeah, sorry. So yeah, sorry for the inconvenience. Yeah, as mentioned, I am Nicolas Vazquez. I live in Uruguay. I'm based in Montevideo, which is the capital city of Uruguay. Uruguay is a small country in the southern east coast of Latin America, and it's the small red dot there on the map, which is located between two giant countries, which are Argentina and Brazil. And yeah, so as I work as a software engineer for ShapeBlue, I have joined the company last year, and before that I've been working as a developer for 6 years, and I also been involved in Cloudstack since a couple of years. Working for other companies, I've been started developing features and getting involved with the community. So that was since 2015, and after that I became a committer in 2016. So sorry, I'm not a native English speaker. As Uruguayan, I am a Spanish native speaker, so I excuse myself in advance for any mistake I could have. This talk is going to be about a new feature which we have been working on. I've been working on its development. This feature is available in version 4.11.1, and it is a way to bypass secondary storage while you are trying to deploy VMs and register templates and ISOs. So I'm gonna try to show you the advantages of doing that. And yeah, this feature is being implemented in KVM as a starting point. And yeah, we'll try to see which improvements can bring on performance, and we'll see that. So I'll start by first giving a brief introduction for those who are not used to the template and ISOs registration process, and then I'll move to this new approach with templates and ISOs registration. After that, I'm going to explain how VM deployments are treated with this new feature and the additions on the KVM agent. And lastly, we're gonna talk about the Metalink support, which is also introduced by this feature. So yeah, let me start by briefly introducing the templates and ISOs registration. So I see many of you guys in the community are here, and you are already used to this process. But for someone who's not into Cloudstack, I would like to first start introducing how this works. So to register a template or an ISO, the user has to provide an URL, which is the URL for that template, and then a download task is sent to secondary storage VM, which it's delegated to download that template from the URL and store it into secondary storage. So once that template gets downloaded and secondary storage, it becomes usable. So in this diagram, I try to represent how it has been working for several years, the usual templates registration process. So yeah, we can see that the secondary storage VM is the one which has the task to download the template, and then that template gets stored into secondary storage. So when a user would like to deploy a VM from that template, and that template is not on primary storage, we'll need to copy that template into primary storage. So what I try to represent on that equation below the diagram is the time which takes to to make a deployment from scratch. And you'll see that there's a time to download the template the first time into secondary storage. Then, well, there's an idle time in which the user did not want to do anything with the template, but we consider that. And then, whenever he wants to use it, we need to copy that template into primary storage, and that involves a network copying from that template to secondary into primary. So what we would like to avoid is to using secondary storage in this equation, and what we are presenting today is a new way to just sending these download tasks directly to the host. So in this way, we'll see that we get reduced of that time. So whenever the template needs to be downloaded on primary storage, it gets there without the secondary storage cache. So this is the new approach that I am presenting with this feature. And to make a brief summary, we are by this approach, what it is in short is that the template gets into primary storage whenever it's necessary, and it becomes usable for users immediately after it gets registered. And I'm going to talk about that in a few seconds. Another remark is that it is only available for KVM at the moment, and if you want to try it, it is available from Cloudstack 4.11.1 or latest versions. So let me now show you how it is now working in a high level. So what we now are doing is whenever the template gets registered, there is a new check performed by the host. So we delegate a task to the host in order to verify that the URL is reachable. So in order to avoid failing deployments, because if the template has to be registered and then a user wants to deploy from that template, but the URL is not reachable, then it will have a failure. And a way to try to prevent that is to randomly select a host and delegate the task to verify that URL. So in this diagram, we'll see that we have provided a way to tell the host that it should look for the template URL. And if it is successful, then Cloudstack needs to update its database to be consistent with the template registration. So the difference from what was the usual approach is that the register template and register ISO APIs were extended. They accept now a new Boolean parameter, which is direct download. And you can see it in the UI. It's represented with a new checkbox only when the KVM hypervisor is selected. And when that checkbox is clicked, you'll also be, we are also displaying the checksum. This is very important because as we are now downloading directly into primary storage, it provides a a way to ensure that that template is the one that we want. So, as you may know, the checksum, it's compute after the file is downloaded, and it is compared to the one that the user provides, just in order to prevent corrupt files. So how Cloudstack is expecting this checksum is, it is mentioned there. Its format is the algorithm between braces and then the hash, the checksum hash. The available algorithms are MD5, SHA-512, and SHA-256 at the moment. So, as I mentioned, when the user now registers a template selecting the direct download checkbox or setting the direct download parameter to true, it would now, Cloudstack would now select a host randomly, and it would try 3 times to reach that template URL. So if after those 3 times the template cannot be reached, then the registration fails. And if it is successful, then we need to be consistent with Cloudstack and to add an entry into the reference table, to template store ref table, by adding this this new download state, which is bypass, and the state set it to ready. So by doing that, whenever we want to deploy, and we have indicated that we want to deploy from a template which is bypass secondary storage, what Cloudstack is doing is using a new manager, which is interacting with the host directly and with the management server. So it would first look for entries on the templates pool ref table. The templates pool ref table is a table for reference for templates in primary storage. So if it does not find a reference for that template into primary storage, and that template is to be downloaded directly into primary storage, it needs to download it. So it sends a command to the host to tell them that that template should be downloaded from the URL into primary storage. So once that it's done, then the host sends its answers back, and the template store ref table is updated. So, and then the usual deployment process continues the same as it was before. So we'll need to do this in order to ensure that the template is available at the VM deployment time. So that download manager, direct download manager in orange, is this new manager, which is a pluggable solution, and it's used when the volumes and ISOs are prepared. So why is a pluggable solution? Because, as you can see there, it supports multiple protocols. At the moment, it supports NFS downloads, HTTP and HTTPS, and metalinks. But it is possible to extend them with more protocols. So, yeah, it has the ability to explicitly tell KVM hosts to download templates into a specific storage pool, and it also has the ability to upload certificates into those hosts. The certificates are used for HTTPS downloads, and it also has the ability to set HTTP headers used for these downloads by setting the VM template details table, prepending the word HTTP header as shown on the slides, and then the name of the HTTP header. In that example, we wanted to pass content type, and we have added these values on the Cloudstack database. So our new manager will pick those up and send them to the host for the HTTP downloads. So as I also mentioned, there's a way to provide certificates to those hosts, and it is through a new API, which is upload direct download certificates. What they basically do is letting the host add their own certificates into their cloud.shakes key store, which is a key store file introduced by the CA framework. And it is used for HTTPS direct downloads. So now let me show you the new additions into the KVM agent, right? So now the KVM agent is receiving new direct downloads commands, which are for HTTP, HTTPS, NFS, or metalinks. So each command is executed by a new downloader, and each downloader, as I mentioned before, it's a pluggable solution, so it can, if we want to extend this functionality for new protocols, we need to make sure that we implement these methods to download templates into a specific storage pool, to extract and install them, to get the information after it is installed, and to validate the checksum. So after it gets downloaded. At the moment they are all Java based, but initially for Metalink downloads we were using the Area 2 binaries, but to avoid some conflicts with the Apache licensing, we have decided to move it to a Java-based implementation for Metalinks. So I've been talking about Metalinks, but let me now show you what a Metalink is, what it looks like. It is basically an XML file which contains some URL tags. As you can see, it has 2 on this case, and it can have a priority property. So it would work as the lowest the priority number, the highest the priority it has. So our Java-based downloader for Metalinks is now considering these priorities, and it would iterate through these URL tags on the highest priorities first, and it will try to download the template. So if it fails for the first one, it would try to the second and on. And we can also set the checksum. As you can see, the hash tag there, it is also possible to be provided. So it is now supported for both direct downloads or usual SSVM downloads. So what that means is that for KVM hypervisor, you are now able to register Metalink templates. So I'm going to do a brief demo after this, but would like to mention some points for further reading. You can find the feature specification on this link, and you can find the PRs from which this was introduced. So let me briefly go to the demo. Okay, I have my small local environment with one host here. So I'm gonna show you how this works. So I'm gonna try registering the Machinina template. Okay. So now let me show you. Yeah, I'm telling the host logs at the moment. So I would try to register a template as a user. And the same goes, everything I have mentioned is analogous for ISOs, right? So for the sake of simplicity, I'm going to do it with templates. But let me just start registering. And we can see that, yeah, it's first checking the URL on the host. So this command came to the host as a check URL command. And after it checked it, it registered the template successfully. So if we now check the template, we'll see it's usable, and we'll also see its status is bypass secondary storage. So after I registered it, I'm now able to do a deployment from it. And I'm not gonna fully show you the behavior as it may vary as I am from my cell phone, but let me show you the logs on the host. Yeah, so we see that it is downloading the template from this URL sorry, into primary storage. So yeah, this would take time because of my connectivity issues, but yeah, this is the way to work with it. Oh, sorry. Let me briefly go to the last slide in which I was. So I now will encourage you to use this feature and to provide feedback, and I open the room for any questions that you may have. Sorry? I cannot hear.
So the idea of the optimization is that the download from the internet primary storage
Yes.
is faster than the public website.
Yes. So the idea is to avoid downloading it once from secondary storage, storing it there, and then have to copy the template into primary. So imagine a big template which you have to download from the internet into secondary storage, and then you have to again copy it through your network again to primary storage. So yeah, the idea is to directly go to primary storage without having to copy this template. At the time of registration, yes. Yeah, after it gets downloaded. Sorry? Oh. Yeah.
So what happens if you, does it ever, like say for instance, if that same template is needed on another cluster, does it get copied to secondary and back down?
No.
Or is it then specific to that?
Yeah, it will try to avoid using secondary storage. So if you mark it for direct download, for direct download, it would, and if it's not available on that storage pool, you download it again.
Oh, okay.
So if you already have it, then you just don't need to download it again, and you don't use secondary storage at all. Yeah.
That's the only way you would be
how do I what, sorry?
How do you enter the XML or the meta link in the UI? Is that possible, or is it just
No,
the,
you just provide the URL. Yeah, so in the URL,
is that a okay,
you
so
point to a
put
meta
the
link.
URL for the
Yeah.
Oh, okay.
So yeah, it now accepts the MetaLink extension. No, it's the same process, but with the MetaLink extension. Marcus?
Yeah, I just want to make a comment, because I have some history with this feature, that the goal is, if you can imagine, you've got 10 zones, or, you've got 10 secondary storages, right? And you've got 5 terabytes of templates, and you have to seize that to the primary zones. So that's a lot of work, that's a lot of downloading to get 10 different manifest storage. There's a lot of storage across all that. So instead, you just push it to your web server that you use to see all your environments, and it just gets downloaded whenever it's needed. And it's done. So that was one of the motivations.
Sure. Okay, any other question, guys?
So how do you prevent a race condition? So say, for instance, one, you've got this storage pool, it needs to download it, and you're spinning up another VM to reference that same template.
Yeah. So what is your question? So
How do you prevent more than one thing in the same primary storage downloading?
so with the template storage pool reference, let me show you. With this, each time we download the template, we make sure we update the database. So the next time we'll check the database, there will be an entry there. So we don't download it again. So that's the way.
But usually there's just one secondary storage medium, right? But this,
Sorry, I can't hear you. Okay, what was the question? Ah. If you can use the... Oh, okay. Yeah, you can. So you can register templates as you were registering by just providing the URL. So what now it has changed for KVM, you are now allowed to register metalinks too, if that was your question.
So I think there's a prepare API where you can basically force it to download like in advance before it's actually required by API. Right? Is that what you're asking? About is the prepare API? Are you asking about the prepare template API, or what is it called, where you can actually set it to the primary storage before it's needed?
Okay. Was that your question? Okay, you know what? We can see it right after this talk. Okay. So any other guys? If you can disable, no. But you can disable it, but by not selecting this parameter here, or not selecting this checkbox. No. So if you mark it for direct download at registration time, it should be there as a direct download. So yeah, you need to be sure when you register if you want it for primary storage or not.
And can you change the checksum afterwards?
No. So it is also set.
If I change the and I want to use
Yes.
And then recreate it.
Actually, yeah, there's not an API for that. You should update the database, but yeah, it would.
Yeah, that was actually, the checksum is there for security, right? So someone can't go and change your data, like, so the template is actually where the data is going to be when it actually comes to download it to this layer or whatever.
Okay, any other question, guys? Okay, so thank you all.